Lesson 5.1, Solving a System of Equations by Graphing. A system of equations is when we have two or more linear equations. When we try to solve a linear system, we are looking for one common solution. This common solution is the exact point where the lines cross. So we're talking about two or more lines, and we're looking for a very specific point where those lines cross one another. When we solve a linear system, we have three options of how to solve a linear system. In this lesson, we're going to look at an option which allows us to graph the lines, and then we can find the solution just by looking at the picture. We can say, by looking at our graph, what is the point where the two lines cross? So let's begin with system number one. Let's take our first equation and let's graph that in red. Okay, we have a starting point at 4 on the y-axis, and we have a slope of -1. So let's make that into a fraction by putting it -1 over 1. Okay, so let's go down 1 and forward 1. Down 1, forward 1, down 1, forward 1. And we want to make several points when we're solving a system. Okay, we want to make quite a few points to connect our line. So there's line 1. All right, line 2 I'm going to make in blue. So in line 2 we have a starting point at 1 on the y-axis. And again, our slope is -1, so let's make that into a fraction by putting it -1 over 1. So we go down 1 and over 1, down 1 and over 1, down 1 and over 1. And remember, we're looking for a point where these two lines are going to cross. But hopefully what you're noticing is that these two lines are parallel to each other. In other words, they're never going to touch. They're never going to cross. So when I'm looking for a solution to this system, what I have to say is no solution. These two lines are never going to touch each other, so they're never going to cross. So system number 1 has no solution. Let's look at the second system. Let's do the top line in red. We have a starting point at 4 on our y-axis. And we have a slope of -1/3. So that means we go down 1 and over 3. So down 1 over 3, down 1 over 3. And remember, we want to do that several times. Okay? If I want a few more points, remember, instead of going down 1 and forward 3, I can do the exact opposite. I could go up 1 and backwards 3. Notice that that point is on the same line. So let's draw our line. Okay, and let's get line 2 on our graph. I'm going to do that in blue. On line 2, I have a starting point at -4, and then I have a slope of 1. So let's make that into a fraction by putting it 1 over 1. Okay, up 1 over 1, up 1 over 1, up 1 over 1. Notice it looks as if I'm headed for the red line as I continue going up 1 and over 1. So right here, we have found the spot where these two lines cross. Now, the solution has to be an ordered pair. It has to be an ordered pair that describes the exact spot where these two lines cross. So, in an ordered pair, remember we give an x and a y coordinate. So if I look on the x-axis, I come over to 1, 2, 3, 4, 5, 6. So my x-coordinate is 6. And then I go up 2 spots on the y-axis. So 6, 2 is the exact location where those two lines cross. That's our solution. Let's try another system. Line number 1 says y equals 1/2 x plus 2. So our starting point is at 2, and we have a slope of 1 over 2. So we go up 1 over 2, up 1 over 2, up 1 over 2. Line 2 is y equals 1/2 x plus 2. It's the same equation, right? It also has a starting point at 2, and up 1 over 2, up 1 over 2. And so here's the deal. When we graph those two lines, there's our red one. The blue one is in the exact same location. So remember, to solve a system, we are giving the exact location where two lines cross. Well, these two lines, the red and the blue ones, they cross here at 0, 2. They cross here at 2, 3. They cross here at 4, 4. They cross here at 6, 5. They cross every single point on these two lines. So we can't give an exact solution. What we say is there is an infinite number of solutions. There are so many places where those two lines cross that we can't list them all. It's infinite. So consider we saw three things in these first three examples. We saw two parallel lines, so they're never going to cross. The solution to that system is no solution. We saw two lines that crossed. We gave the exact ordered pair where they crossed. And now we see two lines that are in the exact same location, and we give our solution as infinite. Let's look at one final example. We have a line that says y equals 5. Okay? That means this is a line with no slope. It's going to be horizontal. So we go up to 5 on the y-axis. We put our dot, and we draw a horizontal line straight through it. Okay, let's do our second line here. But notice that line's not in slope-intercept form, so we've got to get y by itself first. So I'm going to do my work right over here. 2y minus 4x equals 2. I'm going to add 4x to both sides. So now I have 2y equals 2 plus 4x. Now I'm going to get y by itself by dividing by 2. And I get y equals 1 plus 2x. But of course in slope-intercept form we want the x first. So y equals 2x plus 1. So let's graph that. We have a starting point at 1 and a slope of 2 over 1. We go up 2 over 1. Up 2 over 1. Notice that the blue line is going to cross over the red right here. So remember, let's give our solution as an ordered pair. We go over to 2 on the x-axis and up 5 on the y. So these two lines cross one another at 2, 5. Sometimes we might be asked to check an answer. I want to know if I were to graph these two lines, would they cross at 2, 1? All I need to do is check it. Now, I don't need a graph to check it. Remember, in an ordered pair, the first number stands for x and the second stands for y. So let's take this x and y and plug it into these equations. Okay, let's plug it into the first one here. I take the y coordinate and I put it right there. 1 equals 3. And I take the x coordinate and I put it right here. So times 2 plus 2. Let's solve that. 1 equals 3 times 2 is 6. 6 plus 2. 1 equals 8. That's not true. Okay, 1 does not equal 8. So that means that 2, 1 is not a solution to this system. It doesn't work when you plug it into the top equation. Even if it works in the bottom one, that doesn't matter. Remember, the solution is a point where two lines cross. So that ordered pair has to fit in both equations, not just one. So this is not a solution to this ordered pair. The ordered pair would have to work in both in order for it to be considered a solution.